Hi, today I'm going to show you how you can use a PolyUMod material model in MSC Marc. And I'm going to go step by step in how to set this up using Mentat from MSC Marc. And in my example, I'm going to start with this material model. It's the PolyUMod Bergstrom Boyce model. That is a good model for rubbers. And it doesn't really matter for my example which of the PolyUMod material models that I use, but this one I selected here. So I had already very quickly calibrated it approximately to this data. Here are the parameters that I want to use in MSC Marc. So the first thing to do, as we always do, is we export this material model to MSC format. So we just click on Export Model, and then I select this one here. I'm going to save it in this location, and there it is. And now I'm going to go over to Mentat. Here's my fresh window of Mentat. But before that, maybe we can take a quick look at the file that we just exported. There was this one, actually. And it contains these commands that we then will use within Mentat to set up our material model. So here it is. I'm going to hide that. I'm going to hide that. And back in Mentat now. So I'm a beginner of Mentat. I'm going to show you how I set up this very simple example. Perhaps there's some shortcuts that you can tell me about if I'm doing it in a different way than you would do. I'm going to start by setting up a grid here. I'm going to edit my grid so it is covering the regions that I'm interested in. Here it is. And then I'm going to go to Geometry and Mesh. And I'm going to add some nodes. I'm going to create 4 nodes for us. So let's get started here. First node, second, third, fourth. I'm going to add a single element between these nodes. I'm going to just do 1, 2, 3, and 4. That's our 2D element. Now, what I want to do is I want to subdivide this element into many elements. So I'm going to click on Subdivide here. I'm going to do 8 subdivisions for my little test case. I'm going to subdivide the elements. I'm going to select all elements. And here they are. So now I created this 2D problem. I'm going to now change this to a 3D situation. I'm going to rotate my coordinate system a little bit. I'm going to expand these elements into 3D. I'm going to translate it in the C direction. I'm going to do 0.1. I'm going to do that 8 times. Expand elements, and here they are. I'm going to save this. I'm going to save as. I'm going to save it here as the name sim. Then I'm going to rotate this into this framework here. So this is my very simple mesh now. The next thing I'll do, I sweep this to remove unneeded nodes that were created. So I'm going to sweep nodes. I'm going to select all of them. It deleted 85 duplicate nodes. OK, I'll save this. So this is our simple problem. The next thing I'll do is I'll create a geometric property, a solid. And here it is. I'm going to add all the elements to this. Here it is. Now we have a solid here. And I'm going to do and set up the material properties in Mentat. I'm going to do new, standard. And for my example, I want to use the PolyUMod library. And the PolyUMod library is available through the hypoelastic option here. And I use user subroutine hypoela2, and I pass in deformation gradient and rotation tensor. So this is a default setting that's good enough. Sometimes you may need density. We're not going to use it here. Elements, I'm going to add all elements. And here they are to that. So now we have a material. I'm going to then switch over to boundary conditions. I want to hold the backside here fixed. So I'm going to start by defining the fixed boundary conditions on the backside there. Here is our dialog box. I'm going to call it fix back. I want to lock all the displacement conditions here. I'm going to select all the nodes on the back. So those are from the, if I look from the right side here, then I can add nodes, and I just drag a little rectangle around these here, and then I select those. I have now, I can go back to this view. I have selected the back side to be fixed. I'm going to pull on the front in the Z direction. So I'm going to add the boundary condition there. New displacement. I want to call this move front. I want to only apply a Z displacement on those. I want to move these with a certain table or history of deformations. I'm going to create a table. I'm going to use create and assign a table here. And I'm going to create and assign it here. And here is this one. I'm going to add points to my table. I'm going to start by 0, 0. I'm going to do, after 1 second, I want it to be 0.1. So that's my value. Those are the values in my table. If we want to look at these, we can plot them side by side here. I'm going to just get rid of this and only look at our mesh. We need to assign this to some elements, or nodes. So I'm going to look from the right. I'm going to add nodes. So I'm going to draw a little rectangle here. I'm going to select those. And then I'm going to switch back to this view. And we can see that we have applied the displacement on those nodes with that table that we just specified. I'm going to go to load cases now. I'm going to add a new static load case. Here it is. And I'm going to simulate 1 second for no particular reason here. We can change that if we were interested in. I'm going to change to an adaptive multi-criteria for the time stepping. Click on parameters, you'll see that the default time stepping is good enough in this case here. So I'll keep that. And I think that's all we need to do for this load case. Next thing we'll do is to go to job. I'm going to create a new job, structural. And I'm going to add this load case to my job. Large strain. I'm going to go to analysis options. I think are fine, so I'm not going to modify those, but you can look at those if you're interested in that. I'm going to go to job results. For our example, that's going to save stresses and the equivalent von Mises stress. Is that it? I think that's it. And then job parameters. Let's go over here. The job parameters is important because here's a number of state variables that we need to specify for our PolyUMod material model. So let's take a look at that. So back here, you can open one of these files. Here's a set number of state variables. This is the file that was generated by MCalibration. It says that should be 14 there. So if I go back here, we should make this 14 for this particular PolyUMod material model. Different material models will have different state variables. So we set that there. And then I can go to input file text because we haven't actually specified the PolyUMod material parameters yet. So we'll do it this way. I'm going to read mol text file. I'm going to switch to this file that we just created here. Here it is. This is all the lines in that file. The first portion of this we don't actually need. These are more or less information for us. So I'm going to manually remove these. The state variables we already specified. And then the rest of these is important. So I'll keep those. That's what specifies our material. You can save this. Normally, you would just click run and run this. But when it comes to Mentat, it appears that Mentat can't run a PolyUMod material model from in here. We actually have to run it from a command prompt. So I'll show you how we do this. So I'm going to say OK here. I'm going to save this again and file. I'm going to export this as a Marc input. I'm going to save this as sim.dat here. Then we can look at this file quickly. Here it is. I'm going to open this with a text editor. And here's the file that we just created. We go to the bottom. Here's the material model that we read in from MCalibration. So we go back here. We can now run this. To run this, what I often do is I have a bat file on Windows. I'm going to open this with a text editor, and this is what it contains. It says call and the version of Marc that you want to run. Then it has the sim.dat file. Run it not in the background. Run it without asking, and here's the location of the PolyUMod library. So I'm going to run this bat file for us by double-clicking on it. And it shouldn't take that long. It needs to grab a license, and then it starts running a little bit. And it finished. So I'm going to scroll up to the earlier on here and see what it looks like. Here you can see that there are some messages here that shows that Marc, we're finding the PolyUMod library. This is version 703, and that's a good thing to check for sometimes. So here it is. We created the results files here. We can also look at the STS file, which is an interesting file. It shows the time stepping that was followed by Marc in this case. And I'm going to go back to Mentat. I'm going to open the results file, open. And this is the file that should contain the results for us. And here is the deformed mesh. We can plot, say, the von Mises stress here. And here's the von Mises stress. I can rotate this around. And that's how it works. So this shows how you can take the MCalibration material model of the PolyUMod style and put it into a Mentat, create the material model, and run it in this fashion. So this is how I would do it. And if you have any questions on any of this, you can ask them below.